Okay. See, you have this diagram there in 8. If you have the question there or on your phone. So what you got is what's it? 1, 2, 3, 4 batteries. Each battery is 1.5. So first question, how much is the total voltage for this if each battery is 1.5 and you have 4 batteries? Yeah, which is 6 then. 4 multiply 1.5. Okay. Calculate the total resistance. So first I'll add the 200 and the 50 together. So we have to use this formula. So that means R is equal to 40. So now you have a 40, a 40 and a 20. So therefore adding those 3 together, R total is 100 ohms. So in fact we can redraw our circuit like this.
Well, you want the equation from A to B.
I've just done B.
A to B.
Oh,
So
you're right, not including the 20. Thanks, Andy. It's just 80.
I also B.
You did the same thing as me, yeah. So they want you to keep the two separate for some reason, alright? So now it's like you have a 80 here, and then it's like you have a 20 here, and then it's like you have a 6 volt here. Okay, and this question is, what's the current through the 20 here? Now, I think we'll use, we can use V equals IR, but the problem is we don't know the V. Because remember, that 6 is for the whole circuit, not for the voltage through this one. So if we use V equals IR, we get R equals V, we're looking for the I. So we get I equals V over R. And although we know the R, we don't know the V. Likewise here. So anyways, we'll use Kirchhoff's loop rule. So we start off with 6.
So why can't the voltage be 6?
It's definitely not 6, because the voltages between these two here must add to 6.
Oh, we don't want the total current.
Oh, okay, you want to do it as a total. Yes, well then the R wouldn't be 20, it'd be 100 then.
Yeah.
Yes.
The
Can
current,
You can do that. You know what? I'll do it both ways. Okay?
the current is the same.
It is, yeah. I'll do it both ways. So first we're using Kirchhoff. So you get, start at 6, then minus I, yeah, minus the voltage here. Remember V equals IR. So minus I times 80, minus I times 20. Oh, actually that's nice enough too. So we get 6 equals 100I. So I equals 6 over 100. That's using Kirchhoff, which is 0. I don't know if it's Kirchhoff or Kirchhoff. Remember, I think I said this in maths class, you pronounce things the way you hear your teacher say it. Now, using it the other way, you suggested thinking about it as one total resistor of 80. So this is 6 and this is 100. So we can just use Ohm's law on this circuit.
In the second.
Yeah, it'll be V equals IR. So 6 equals I times 100. So then I equals 6 over 100 equals 0.06. So we get the same answer both ways, and both are fine. So this is using Ohm's law, but you have to write it as one resistor, and then this is using Kirchhoff's first rule is loop rule, which I know you missed that class, Habib, Kirchhoff's rules.
Is it 20? Between the bracket?
It is, yeah. Okay.
I'm not done yet, right?
One part left here in this.
We need the V.
No, he wants the I. Yeah, and then the last part now he wants the V. He wants the V through the 41. So the D part now. Now, it's kind of nice that he got us to calculate the I, because here's the 41. Now, you do not know what the V between this resistor is, but the I is the same. Now, I think I said this before, if you look at your circuit, okay? If 1 coulomb per second goes through this resistor, oh wait, which side? Wrong way around. If 1 coulomb per second goes through this resistor, then, well, actually let me draw it on the screen to explain on the side here. Okay. 1 here, then 2 here, then basically 1 here, then all the way back. Sorry about this rough diagram. It's just to make a point here. Here is I, you know, maybe like, oh, we have the I, what was it, 0.06. Here's the I, here's the I, here's the I, but here it splits. So if we call this I1, then this will be I2 and I3. But remember when we were doing Kirchhoff's, I said if I1 is coming out, then I1 must be going in as well. Just like people walking down a corridor. If one person enters at the bottom, then one must leave at the top. Anyways, that means that here is I1 and here is I1. So as long as you don't care about this piece, it's the I here and here is going to be the same answer that we got previously. So when I say V equals I or, I actually know the I and the or. The I is 6/100 and the or is 40. So what's that? 2.4, yeah. Volts. Okay, and then that's that one done. What's wrong, MB?
Next one.
What?
So that's fine.
The next one? A bit. Okay.
Just proving the formula.